Okay, this video is on angles. So we've got the different types of angles. So we've got an acute angle, which is smaller than 90. We've got a right angle, which is 90 degrees. And if it's bigger than a right angle, it is obtuse. So that's between 90 and a straight line, which was 180. We've got a straight line, which always adds to 180. Reflexes are bigger than 180, and a full turn is 360. So we need to remember these, especially that 180, 90 and 360, because things will often add up. So here's my first question, and this one is on a straight line. So we know automatically that it adds up to 180. So if I just write it out as an equation, we know that x plus 47 plus, and this is that right angle, so 90, is equal to 180, that straight line. Sorry about my not brilliant writing right there. Okay, so because these are on the same side, we can add them together. So we've got x still, if we're collecting, because there's no other x's, plus 90 plus 47, which is 137, makes, and some of you will have jumped straight to that one instead of doing your top one, which is absolutely fine. You don't have to write every step of this out, but if you make an error, at least you get marks if you've written every step out. So it is good practice. So then if I subtract 137 from both sides, then we know that x is 180 subtract 137, which is 43 degrees. Okay, so that we know that x is 43 degrees. Okay, my next question. We've got a triangle, and we know that triangles also add up to 180. Another one for our head. And quadrilaterals, any four-sided shape, must add up to 360. We've got exterior angles, they're the bit on the outside. So an interior is the bit on the inside. So we've got the interiors here on the inside. And the interior and the exterior together will always make 180. So any of those exteriors are just an extension of that interior line, which make the interior and exterior add to 180. But another key thing to remember from these is that all of those exteriors together will always make 360 on any shape. So on this pentagon, these exteriors still make a full turn and will make 180. And on this one, all of these exteriors will still make 360 if I sum them all together. So those are the two things that I always remember about interior and exterior angles. The interior and exterior make 180, and the sum of the exterior is 360. So we're going to use those now. So regular polygons, we know that the sum of the exterior is 360, but we can use that to make this sort of equation. So these are just the same equation written in two ways. So either the number of sides is 360, so the sum of the exterior divided by the exterior angle, or if we want to find the exterior, we can just do 360 divided by the amount of sides. And that will be really, really useful to us. So if I was given no picture, but I know I've got 10 sides, what is the exterior angle? Well, I'm going to do 360 divided by 10, because that's the number of sides. So I know every exterior angle will be 36 degrees. And so if I wanted the interior angle, well, if I think back to knowing that exterior and interior add to 180, if I do that the other way round, I know that the 180 subtracts that 36, that exterior angle. So if I do 180, subtract 36, I know that that interior angle, so the one on the inside of the shape, would be 144 degrees. So on a decagon, a 10-sided shape, I know that the interior angle is 144. Okay, so for this one, I know that the interior angle is 150. But remember, exterior was the one that could be used in the formula. You have got the other formulas, but this one is much easier to use. So if the interior is 150, I know that the exterior needs to add to 180. So I know that that exterior angle is 30 degrees. So then if I use my formula, I know that the number of sides is 360 divided by 30, which is 12. So it's a 12-sided shape, 12 sides, or a dodecagon. So here we've got a trickier question, much trickier. So let's just read it first. The diagram shows a square, you can see the square just here, and a regular hexagon. So we can see the hexagon there with 6 sides and all the sides the same length. And they meet at a point P, and then we've got our other shape. The first thing they want us to do is show one of the interior angles of the hexagon is 120. So if we think back to that equation that we've been using, 360 divided by n gives us the exterior. So I know that the exterior is 360 divided by 6, which would be 60 degrees. So I've just written hexagon, exterior. What would the interior be? Well, I know 180 subtract 60 equals 120, which is then shown that 120 just there. So we'll be doing 360 divided by 6 is our 60, and then 180 minus 60. So then on to the second part, find the number of sides of the other regular polygons. Well, again, I'm going to put my square, exterior and interior, and then my unknown. So let's start with the square. We know a square without even looking that the interior angles, well, if I could use the formula again, 360 divided by 4 is 90, and then subtract it, but a lot of you will know that square has angles that are 90 anyway. So if you know it, you don't have to write all your work in. That is a bad 9, but there you go. So the unknown, well, let's just draw this onto, so we get points if we can get marks, not points, if we put it on our diagram sometimes as well. So I'm going to just write it on there because that makes it really clear. So I've got 120, I've got 90, so if I do 360 subtract 120, 240, subtract the 90 again, so that is 150, so that is the interior. Okay, so if I put that on my interior, that doesn't help me yet because my formula had exterior in. So I know the exterior is 30, and actually on the previous slide we've already done those numbers. So if I do 360 divided by 30, I know that's got 12 sides. That's my final answer.